Hi students, coming to the continuation basics of the memory organization. In this case, let us see the question number 1. So find the total address lines, here total address lines and data lines for the following memories. So we are going to find out these address lines and the data lines from the given memories. For example, let us start with the first one, 4096 into 16. 4096 into 16. So this is the one memory size. So in this memory size, we are going to find out the address lines and the data lines initially. So before multiplication, this is not a multiplication, that means just using this the cross, or simply it is called 4096 by 16. 4096 by 16. This is by. So here after by 16 is called as a, that means 16 is called as a data lines. Here 4096 is the number of locations. That means this is equivalent to 4k into 16. The memory representation is like this. This is memory. The size is 4k. That means 4096. The word size equal to 16. Here 16 is the data lines. Our word size of this memory is 16. That means inside 4k locations are there. That means 40996 locations. These are the individual location. It starts from 0 location to the last number is 4096. The last location number is 4090 to 4094. This is the representation. Here 16 is the word size. The calling it is a 4096 by 16. 16 is the data lines. Inside 4096 is the number of locations. So coming to this one, data lines are 16 here. From this data lines, word size of the memory. Coming to this address lines, 4096 means 4k. 4k memory size. That means here the simple representation k is indicated. Just differentiate these two. Separate these two. K is equal to 2 power 10 representation. Here 2 equal to 2 power 2. So that means add these two powers. 2 plus 10. Only powers. 2 plus 10. That means 12 address lines. 2 power 12. So these 12 address lines is represented as address lines. So as per this memory sequence, 4096 locations, 12 address lines, 16 data lines. So coming to the second case, 1024 into 8. So in this case, 8 is the data lines. Directly you can say that the memory, the word size equal to 8, the size equal to 1024 means this is the 1k memory size. 1024 means simply 1k is represented as a k means 2 power 10 into 1 means that means 1 power 0 representation. 1 power 0. That means adding these two values, that is equal to 10. So that address lines are 10. So in this case, address lines are 10. So coming to this case, here data lines are 4 and here k means 10. Here k means 2 power 10. Here 8 means 2 power 3. 3 plus 10, total 13. Address lines are 13. In this case, the 16 is the direct data bus length or data lines. In this case, k means 2 power 10, 12 means, that means, so coming to this 12 case, here 12 means, just observe here the actual 2 power, that means 2 power 2, that is equivalent to 4 address lines, 2 power 3 equal to 8 address lines, 2 power 4 equal to 2 power 2. We are going to consider the 2 address lines, here 3 address lines, 4 address lines. Here 8 means directly you can say that 2 power 3, that means 3 address lines we are going to access 8. Here in this case 1k means directly 2 power 0 we are going to consider as a 1. Here 4k means 4 means 2 power 2. Here 2 power 2. But in this case 12. This is not a exactly value. But in this case, in between powers of the 2 power 3 and 2 power 4, in between these two values. That means 12 is the middle value of the 8 and 16. So that the maximum value always we are going to consider. So from 8 to 16, in between these two values, 12 is there. So that 2 power 4, that is equal to 16. So we have to consider the maximum value. So that the 4 address lines we are going to consider. So here 4 address lines. That means 2 power 4. This is not equal to 16, but above this value, 2 power 3 above value, 2 power 4. So the complete value is the 12 is above the above value of the 8. So that we are going to consider 2 power 4 in this case only. So 4 plus that means 4 plus 10, that is equal to 14 address lines. So finally 12k address lines equal to 14 address lines are there. So once again checking this one, 2 power that means 10 address lines, 2 power 10 equal to 1 kilobytes of the memory. 11 address lines, 2 power 11, that means 2k memory address we are going to access in. 12 address lines, 2 power 12 equal to 4k memory we are going to access in. 13 address lines, 2 power 13 equal to 8k memory we are going to access in. 14 address, 2 power 14, so that's 16k address we are going to access in. So in this case, if it is a 8k, so that directly you can say that means 13 address lines. 13 address lines. Here 8k memory is there, so 13 address lines. So, but in this case, in between 12k and 16k, 12k is there. 8k and 16k, 12k is there. So that 8k is already crossed address lines, so that we have to consider 14 address lines in this case.